Moving galvanometer is a device which works on the principle that when a current is passed in any loop present in a magnetic field, it experiences a torque, and due to that torque, it starts rotating. So because of this current carrying loop, एक magnetic torque produce होगा, which is balanced by the spring torque. Magnetic torque का formula था NIAB sin theta. Theta is 90 degree is equal to K times theta. So current in this loop or entering into the galvanometer is directly proportional to the angle of deflection. Deflection per unit current is defined as current sensitivity. याद रखिए हमने लास्ट क्लास में करंट सेंसिटिविटी को हम नंबर ऑफ टर्न्स बढ़ा के इंक्रीज कर सकते हैं, बट वोल्टेज सेंसिटिविटी कैन नॉट बी इंक्रीज बाय इंक्रीजिंग द नंबर ऑफ टर्न्स. Deflection per unit voltage, so that will be theta by I times R. 1 by R into theta by I. Theta by I is the current sensitivity divided by resistance and voltage sensitivity. R is the resistance of the galvanometer coil. So अगर हम उससे current measure कर रहे हैं, means अगर हम उसको ammeter में convert कर रहे हैं, what is the practical meaning of sensitivity? That how small current can be measured or detected by the pointer deflection. If on passing a very small current, it gives a appreciable deflection which can be noticed on the screen, noticed on the pointer scale. That means it is a sensitive galvanometer. Sensitive galvanometer means even a small current can be measured more accurately or without much error. Now, conversion of galvanometer into a meter and voltmeter. That's the next topic. Conversion of galvanometer into a meter and voltmeter.
Sir, can you move to the previous page for a minute?
This might be in your notebook.
Done.
Yes. Deflection per unit current is current sensitivity, deflection per unit voltage is voltage sensitivity. Now, galvanometer has to be first converted into a low resistance device because it cannot directly be used for measuring the current. Current measure करने के लिए हम direct use नहीं कर सकते. Reason being of because of very high resistance. Galvanometer के coil में बहुत सारे loops हैं. That is a very long wire. It is wrapped in the form of rectangular loop of n number of turns. Because of n turns, then the length of wire is quite large, and which gives the galvanometer very high resistance. RG गैल्वेनोमीटर का ऑलरेडी रेजिस्टेंस बहुत हाई होता है, ऑर्डर ऑफ 100 ओम at least, more than that. So because of the high resistance, another limitation क्या है, गैल्वेनोमीटर के अंदर बहुत ज्यादा करंट नहीं जानी चाहिए. The current which corresponds to the maximum deviation or maximum pointer deflection. सेंटर पे 0 होता है, सपोज टोटल 30 डिविजन्स, 40 डिविजन on both side. So this current which corresponds to the full deflection. When pointer is showing the full deflection, and there is a current is called full deflection. This angle is called full deflection. On passing current, the galvanometer pointer moves because of the torque, and the current for which this pointer is deflecting completely or showing all the scales on the pointer scales on the pointer on the scale means this theta corresponds to full scale deflection, and this is the maximum current that can pass. If there's a current more than this, then either needle will break because of the torque, or the galvanometer coil will become heated and it may be melted because of the very high resistance produced. IG and RG, these two are the constant which should be known for the calculation of any conversion question. Full scale deflection current. Full scale deflection current. Usually in the order of milliampere, क्योंकि इसका resistance बहुत high होता है इसलिए. अब गैल्वेनोमीटर को डायरेक्टली अगर हम यूज करना चाहें कि जितनी करंट पास होगी उसी रेशियो में रिफ्लेक्शन हो रहा है, so I cannot use it directly to measure the current in a circuit. गैल्वेनोमीटर में डिफ्लेक्शन करंट के प्रोपोर्शनल है, जितने भी करंट आएंगे के सर्किट में उसके रेशियो में वो पॉइंटर डिफ्लेक्ट होता जाएगा. Now we'll have to see why it is not possible. Galvanometer cannot be used as a device to measure the current. It can only be used to detect the current. Just a second. गैल्वेनोमीटर को उसके हाई रेजिस्टेंस की वजह से हम यूज नहीं कर सकते किसी भी करंट को मेजर करने में. It is used only to detect the current. Let's take one example. गैल्वेनोमीटर का रेजिस्टेंस बहुत हाई होता है, लाइक 100 ओम, 50 ओम, 1000 ओम टाइप्स. In this circuit, we want to measure the current by using the ammeter. Suppose we don't have ammeter, we just connected a galvanometer. गैल्वेनोमीटर को सीरीज में लगाना पड़ेगा क्योंकि तभी उसमें सेम करंट पास होगी जो इस सर्किट में है, एंड accordingly the deflection will give that value of current. So if there is a current, suppose हमने भी गैल्वेनोमीटर लगाया था, मैथमेटिकली कैलकुलेट करते हैं what is the actual current. Meher, Mr. Meher, Meher, actual current कितनी है सर्किट में? Actual current is V by R, so 10 by 5, that's 2 ampere. मेजर करने के लिए हमें गैल्वेनोमीटर को लगाना पड़ेगा सीरीज में, because only then the same current will pass, और that current will give deflection accordingly. हमने मेजर करने के लिए लगा लिया है गैल्वेनोमीटर. We don't have ammeter available, so we use the galvanometer. और गैल्वेनोमीटर में भी करंट के रेशियो में ही डिफ्लेक्शन होता है. So this current will be now measured. मेजर करने के लिए क्योंकि गैल्वेनोमीटर को लगाया है सीरीज में, so now this resistance which is let's say approximately 100 ohm. 100 ohm के ऑर्डर का होता है, हमने 100 ले लिया. So this will now the current in the circuit will drastically change because the overall resistance has been quite high or increased. Measured value of current कितनी हुई? Total current will be 10 divided by total resistance. So जो current गैल्वेनोमीटर के पास होगी, that will be showing the deflection. So this becomes I dash is potential 10 divided by resistance 105. So it is 0.1 ampere. Actual current भी 2 ampere. अगर हमने गैल्वेनोमीटर को सीधे लगा दिया उसको मेजर करने के लिए, then it becomes 0.1. Arnav,
Yes, sir.
did we do this topic last class?
I don't
I have a
think so,
feeling.
sir.
Huh?
No, sir.
But we did moving coil galvanometer.
Yes, sir.
Galvanometer को ammeter में convert करने के लिए वो हमें क्या करना है? We have to somehow minimize the resistance. 100 ohm is not a required thing because it is changing the overall resistance by a very high value, which gives the current very drastically changed. If it would have been 1.9 or 2.1, 1.8 type, then we can still use this. So to convert the galvanometer into ammeter, the necessary and required condition is its resistance should be made as negligible or as small as possible. क्या करने से resistance decrease होता है? I mean,
So we can shunt it by putting it in parallel with a really high resistance.
yeah, we could have increased the area r equal to rho L by A, length कम कर दें, लेकिन उससे फिर difference क्या होगा? टॉर्क की वैल्यू भी कम होती जाएगी. अगर आप रेजिस्टेंस कम कर रहे हैं मतलब लेंथ कम कर रहे हैं, लेंथ कम करेंगे तो नंबर ऑफ टर्न्स कम हो जाएंगे, एन भी कम हो जाएगा. सो दैट ऑप्शन इज नॉट a very good option that we can reduce the length or we can increase the thickness, something like that. So alternate option is we reduce the overall resistance, not just galvanometer coil. Galvanometer coil का तो जो है सो है. Galvanometer resistance can be minimized by using a very small resistance in parallel. Like suppose even if इसका 1000 ohm भी होता, let's say just for an example, even if it is 1000 ohm, हमने इसके साथ पैरेलल में लगा दिया एक बहुत ही छोटा सा रेजिस्टेंस 0.1 ओम का या 1 मिली ओम का. That external resistance should be very small and it is as small as possible. मतलब kind of negligible. and then overall resistance, this is called shunt. Shunt is an alternate path. So conversion of galvanometer to ammeter is by connecting a very, very low resistance in parallel with the galvanometer coil. For example, when this galvanometer is 1000 ohm resistance, the resistance of this ammeter will become how much? R1 into R2 divided by R1 plus R2, which is 100 divided by 1000.1, so approximately 0.098 something. Overall resistance of this meter become even quite less than 0.1. So this won't harm much because the resistance even after connecting this in the series will not be changing much. Right? Galvanometer conversion into ammeter. To convert a galvanometer into a meter, a very small resistance is connected in parallel with the galvanometer coil. This small resistance has two roles. Into a meter, a very small resistance called as shunt is connected in parallel. Is connected in parallel with galvanometer coil. Right. Okay. So galvanometer को convert करने के लिए हमने example समझ लिया that a galvanometer high resistance can be minimized to a very, very low resistance by connecting a very small resistance in parallel. RG तो जितना था ही, we have connected a very small resistance in parallel that will cause the overall resistance to be minimized. Plus, it also increases the range. कैसे? Galvanometer में जो maximum current जा सकती है वो fix है. If suppose we have to measure the more current or greater current than the full deflection current, this shunt will also allow to extra current or excess current to pass through it. Suppose capital I is 20 ampere and IG is only 1 milliampere because that is a very, very high resistance. So galvanometer से बहुत कम current जाएगी. The rest of the current will be bypassed. So the shunt reduces the resistance of the ammeter as well as provides an alternate path for excess current to pass. So both are in parallel. In parallel, the potential is always equal. IG into capital RG will be equal to I minus IG times RS. IG क्या है? Galvanometer से pass होने वाली full deflection current, full scale current, maximum current that can pass. Capital RG is galvanometric coil resistance. I is the total current that enters.
Sir,
Yes.
can you move to the previous page for a minute?
भरत बेटा ये जो हमने एग्जांपल लिया था ये आपको एग्जाम में नहीं लिखना है इन केस दूसरे एग्जाम में सब्जेक्टिव आएगा नहीं फ्रॉम दिस चैप्टर बट स्टिल it should
नहीं,
not be
Sir, in class notes. I'm making in class notes.
very good, yes. Understand that this was an example to make clear why the direct galvanometer is not fit for measurement because it will have affected the overall resistance so badly that the current will become 1 by 100 time, 1 by 10 times, something like that. So galvanometer reduces current by a huge amount. So to maintain the same amount of current, we'll have to make it into a certain device which resistance is almost negligible. Ideal case would be zero resistance. So if there is a
That is a
real
superconductor,
emitter,
right?
beta?
You're talking about a superconductor, right?
No, not so superconductor. Superconductor is entirely different thing. हम एक galvanometer को zero galvanometer को as small as possible resistance में convert कर रहे हैं या करना चाहते हैं. That is the goal. As small means if it becomes perfect zero, which is a hypothetical case by the way. क्योंकि अगर सुपर कंडक्टर होगा बेटा तो उसमें करंट सुपर कंडक्टर में कुछ और कहानी होती है. देयर इज नो इलेक्ट्रॉन फ्लो, देयर इज समथिंग एल्स, इलेक्ट्रोमैग्नेटिक इंटेंसिटी वेक्टर. Zero resistance is a hypothetical thing in this particular case क्योंकि हमने वायर यूज किया है. So in the case of wire it is not possible. गैल्वेनोमीटर के साथ पैरेलल में एक छोटा सा रेजिस्टेंस लगा देते हैं. Small rs is that shunt resistance which is required to be connected. Ig divided by I minus Ig time capital R. This is the shunt resistance required. Shunt resistance required to measure current up to capital I. Capital I here is the range of ammeter, and so basically हम measure तो capital I कर रहे हैं using this device, but galvanometer में पास कौन सी हो रही है? Only Ig. Ig is a small fraction of I which causes that pointer to rotate or deflect, and accordingly we will find out the relation. I is range of ammeter, Ig is galvanometer current in galvanometer, and obviously capital Rg is galvanometer coil resistance. अभी हमें ये भी प्रूव करना है that I should be directly proportional to Ig, क्योंकि हम मेजर करना था हमें I, but I के हिसाब से यहाँ पर डिफ्लेक्शन नहीं हो रहा है. Deflection is because of Ig. So we also need to prove that Ig is directly proportional to I. Ig into Rg. Right side से Ig into Rs को लेफ्ट में ले आते हैं is equal to I into Rs. Just rearrange all the Ig terms on one side. I will become Ig times Rg plus Rs divided by Rs. The total current will be Ig into Rg by Rs plus 1. I comes directly proportional to Ig and Ig is proportional to theta. So by that logic, we can use this current Ig. राइट, सो इसमें एक चीज और क्लियर हो गई क्या, रेंज जो है वो बढ़ती जाएगी अगर हम शंट छोटा करते जाए. The range of ammeter will be increasing with smaller value of RS, क्योंकि RS है denominator. The lesser the shunt resistance, more will be the current passing. Is that clear? ये समझ आ रहा है ना? अमीटर में वो आपको कैसे कन्वर्ट करते हैं, आप अमीटर में जो सॉरी कैलोमीटर में जो करंट है तो फुल डिफ्लेक्शन करंट, उसको रिप्रेजेंट करने के कुछ अलग अलग तरीके होते हैं. कैसे? एक तो ये डायरेक्टली गिवन हो सकती है, और अल्टरनेटिवली इट माइट बी गिवन कि per division current is 1 microampere. Let's say it says that 1 microampere per division. Either it can be written as 1 micro. Just a second. So these information can also be given in this term, like either it may be given as 1 microampere per division, or it can be given as 10 division per milliampere. And suppose total number of divisions. So वैसे तो इनको हम sensitivity नहीं बोलना चाहिए, but question में this is just an extra term, extra information that how to tackle the question language. And it might be given in the name of current sensitivity, while current sensitivity की definition हम पहले पढ़ चुके हैं, that is the deflection per unit current. So वो जो current sensitivity थी, that is the exact definition, but from this sensitivity we can figure out what is the total current passing, maximum current that can pass. Like suppose in this particular ये दो अलग अलग galvanometer है, और इसमें total number of divisions on circular scale is given as 150, let's say. पहले वाले केस में हमें full scale difflection current कैसे मिलेगी? One division is 1 microampere, so 150 division will correspond to 150 microampere. पहला part तो done. In the second situation, 10 division is corresponding to 1 milliampere. 10 divisions on the pointer. When the pointer moves by 10 division, that means current is 1 milliampere. So 150 will be 15 milliampere. Now the only point was, when these value is given, you don't have to stick to the actual definition of sensitivity. You can decide it by using the unit. Like in the first one, it was given current per division. In the second, it is given as deflection, but not for unit current, deflection on 1 milliampere. How much it corresponds to 1 milliampere, right? Yes, got it? यस बॉस, ये समझ में आ गया ना करंट की डिवीजन कैसे हम इंफॉर्मेशन कैलकुलेट करते हैं? इज इट क्लियर? बेटा ये लास्ट टॉपिक समझ में आया या फिर से समझाऊं मैं? इज दैट क्लियर?
Clear.
Okay, let's solve some question. Maybe then it will be more clear. Ideal emitter will be a zero resistance thing, but zero resistance is not practically possible. इसका मतलब हम सीधे शट कर देते हैं. अगर हमने वायर लगा दिया पैरेलल में तो सारी की सारी करंट उसी वायर से जाएगी, zero resistance वायर से. Ideal emitter will not show any deflection, but if for solving unless mentioned the resistance of emitter, हम उसके resistance को zero ही assume करेंगे because it has been made negligibly small. Second, conversion of galvanometer into voltmeter, and then we will solve some questions based on this. Conversion of galvanometer into voltmeter. Again, if suppose we try to use the galvanometer directly without any change. So let's take this same example: 3 ohm, 2 ohm, or a 10 volt की battery. This थ्री ओम, 2 ओम. ये 2 ओम के क्रॉस का वोल्टेज हम मेजर कर रहे हैं. पहले कैलकुलेट करके निकाल लेते हैं, देन वी विल यूज द गैल्वेनोमीटर to measure this voltmeter, measure this voltage. Current is 2 ampere. Let's say current is I, which is equal to 2 ampere. So actual potential difference across 2 ohm. V1 is I into R. अब लगा दिया हमने पैरेलल में ऐसे गैल्वेनोमीटर. 3 ohm, 2 ohm, 10 volt battery. We connected a galvanometer in parallel to this. क्या हुआ फिर? What happened is now that because of the galvanometer connected in parallel, the current is divided. जो करंट पहले जा रही थी इस 2 ohm के सर्किट में, that total current I. Now I will be divided into branches. Some amount of current will start going in the galvanometer, and only the remaining current will pass through this 2 ohm resistor. So the measured value is not 4 or not I into 2. The measured value is 2 into I minus I1. और रीजन इसका ये है क्योंकि थोड़ी सी करंट पैरेलल वाले ब्रांच में डिवाइड हो गई है. मेजर्ड पोटेंशियल डिफरेंस अक्रॉस 2. So because of this current going into the parallel branch, the potential difference will become less than 4 volt. while initially it was 4 volt because current was 2. So in this certain condition, it will basically depend upon the relative magnitude of resistance of this coil, resistance of the galvanometer, and the resistance of this particular wire across which we are measuring it. गैल्वेनोमीटर में करंट जो जा रही है उस करंट को अगर हम मिनिमाइज कर दें as small as possible so that almost all of the current is passing through the 2 ohm only. पहले करंट जो थी आई उसका थोड़ा सा पोर्शन अभी पैरेलल वाले डिवाइस पैरेलल वाले ब्रांच में it has been distributed in these 2 branches. The current that goes in the galvanometer is negligible अगर उसका रेजिस्टेंस बहुत हाई करते जाए. जितना हाई रेजिस्टेंस होगा उतनी कम करंट पास होगी. So if the resistance of galvanometer is increased, when the current will be divided, a very small amount of current will go in the high resistance branch. High resistance, less will be the current passing through it. So to convert a galvanometer into a voltmeter, हमें उसका resistance बहुत बढ़ाना है जितना भी हम maximum कर सकते. In the case of ammeter, we have to reduce the resistance, and in the case of voltmeter, we have to increase it to convert the galvanometer into voltmeter. To convert the galvanometer into voltmeter, a very high resistance should be connected in series. इस series में connect करने पे a very high resistance should be connected in series. In series with galvanometer coil. गैल्वेनोमीटर कॉइल के साथ सीरीज में अगर हम बहुत हाई रेजिस्टेंस लगा देते हैं गैल्वेनोमीटर की कॉइल के साथ अगर हम सीरीज में बहुत हाई रेजिस्टेंस लगा देते हैं the overall resistance becomes very high and that will minimize the current that will be distributed in parallel branch while measuring the potential difference, which ensures that the potential measured and actual is not much different. They're almost same. अब क्योंकि यहाँ पे हम सीरीज में लगा रहे हैं सीरीज में करंट सेम होती है so the same current will pass. IG is the maximum current that can pass through galvanometer, then that will be the maximum current which can pass through the external series resistance also. So potential measured value V is equal to IG into RG plus RS. that is the maximum voltage that can be measured. Resistance, high resistance measured in series. V here is the range of voltmeter. ये maximum value है जो हम किसी भी voltmeter से measure कर सकते हैं. And from this formula, we can also calculate the series resistance required to measure a voltage V. So RS from this formula will come out V by IG minus RG. The series resistance required to measure potential up to V. Very nice. Okay, so if you want this resistance, this value to be closer to the actual value, then the resistance has to be as high as possible. So ideal voltmeter is the one which does not draw any current, means resistance should be infinite. But अगर infinite है तो कोई current pass नहीं होगी, कोई current pass नहीं होगी, तो it will not show any deflection. So that is again a hypothetical thing. But the one we used in the third chapter, so हम कुछ questions कर लेते हैं based on this. I think last class I shared you this maybe, so you can check it in your group again. I have shared yes, this one. Shared this in your group, the magnetic moving coil galvanometer and its conversion. So we'll solve some questions, the one which has a little tricky language. Questions are very easy, direct formula based. Yeah. So पहला question तो theoretical है, second is also kind of theoretical. Let's start with the third one. तो क्वेश्चन में एक तो डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन होता है. अगर हम पहले वहां से स्टार्ट करते हैं, लेट्स डू द इजी वन. लाइक क्वेश्चन नंबर 8, an ammeter reads up to 1 ampere, internal resistance is 0.81. To increase the resistance, to increase the range from 1 to 10, what is the value of required shunt? तो ये ammeter को हम galvanometer की तरह ले लेते हैं. There is already a galvanometer converted into ammeter, but it can draw only 1 ampere of current from the circuit. It can have 1 ampere of current and its resistance is 0.81 ohm. Now it's saying हम कितना shunt लगाएं, shunt का मतलब parallel resistance, so that 10 ampere current can enter. क्या करेंगे? We connect a parallel resistance, a shunt resistance, which will draw all the excess current. Out of 10 ampere, 1 ampere is gone into this galvanometer. मान सकते हैं इसको. It's like a galvanometer only. Galvanometer में कुछ अभी parallel में जो हमने branch लगाई है shunt, that will draw 9 ampere current. So here galvanometer is already converted into a meter, but that ammeter overall resistance is given 0.81. Overall current that it can show maximum is 1. 10 एम्पियर की रेंज का एमीटर बनाने के लिए हमें पैरेलल में एक करंट लगाना पड़ेगा जिसमें कि रिमेनिंग 9 एम्पियर कैन पास. So 9 into shunt resistance is equal to 1 into 0.81. 0.09. Fourth option. Question number 9. You can see the questions are very easy. The only thing maybe become little challenging is finding the value of IG, the information from the. A moving coil galvanometer has 150 equal division. Current sensitivity 10 divisions per milliampere. Now, if you see, 10 division per milliampere is not the standard unit. It is not the standard unit for measuring the sensitivity. But with this information, we can find 10 division correspond 1 milliampere. So 150 division will correspond to 15 milliampere. Right? Right? Moving coil galvanometer has 150 equal divisions. Current sensitivity is 10 division per milliampere. So हम क्या करेंगे? 10 divisions per milliampere. 10 division में 1 milliampere. 150 division means 15 milliampere. So we got IG. अब ये बोल रहा है voltage sensitivity 2 division per millivolt. 2 division में 1 millivolt. So 150 में it will be 75 millivolt. This is the potential difference that the galvanometer can show. So potential difference पता पड़ गया, maximum current पता है, so we can find out the RG. RG, the galvanometer coil resistance is VG divided by IG. VG is 75. RG मिल गया हमें कितना 75 by 15 मिली कैंसिल हो जाएगा. This is 5 ohm. RG is equal to VG by IG, so हमें R मिल गया, हमें I मिल गया. अब ये बोल क्या रहा है, हमें ऐसा वोल्ट मीटर बनाना है जो एक डिवीजन में 1 वोल्ट रीड करे, and total division is 150. So which means the range of voltmeter should be 150 volt. Range of voltmeter. Voltmeter का range What's the answer? हमने इस क्वेश्चन में जो इंफॉर्मेशन गिवन थी वहां से आईजी निकाल लिया. दिस इज लाइक अ ट्रिकी क्वेश्चन. ये जेई में आया हुआ है. एयर ट्रिपल ई मींस जेई मेंस. वी गॉट वी इज रेंज. आईजी हमने कैलकुलेट कर लिया है और v प्लस आरएस. V is 150, IG is 15 milliampere. IG is 15 milliampere, so 15 into 10 to the power minus 3, and RG is 5 plus series resistance RS. So we can find out the value of RS, which is I think 9995. आगे आंसर 10, so 10 into 10 to the power 3, so 103 minus 5. Next question. So here the answer will be second 999. अब आते हैं इस पे क्वेश्चन नंबर थर्ड पे. दिस आल्सो अ सिमिलर टाइप. क्वेश्चन नंबर थर्ड. A galvanometer as voltmeter reads 5 volt at full deflection. Full deflection में 5 volt मिलता है, and graded according to the resistance per volt at full deflection is 5000 ohm per volt. 1 volt के corresponding 5000 ohm है. So क्योंकि ये full deflection पे 5 volt read करता है, so full resistance would have been 5 into 5000. That becomes 25,000 volt. 25,000 ohm. बेटा समझ में आ रहा है? कुछ बोल नहीं रहा कोई. अर्नव, इज इट क्लियर?
Yes, sir.
कर रहे हो ना साथ में? नहीं. You are supposed to solve this question with me. I mean, half of the people is not solving, probably. No one. Colonel? क्वेश्चन नंबर थर्ड, ये क्वेश्चन थोड़े नॉर्मल क्वेश्चन से डिफरेंट है। नॉर्मल जैसे बोर्ड में आते थे उसमें आईजी भी लिखा होगा, आरजी भी लिखा होगा, फिर आपको कैलकुलेट करना है। आई दिस इज लाइक इंफॉर्मेशन एक्सट्रैक्शन फ्रॉम द गिवन वैल्यूज। तो ये बोल रहा है कि फुल स्केल पे 5 वोल्ट होता है रीडिंग, और 1 वोल्ट की करस्पॉन्डिंग है 5000 ओम, यानी कि सीरीज में और जो रेजिस्टेंस मिला लेते हैं, तो व्हेन द रेजिस्टेंस 5000 देन इट करस्पॉन्ड्स टू 1 वोल्ट। 1 वोल्ट के लिए 5000, सो 5 वोल्ट के लिए 25000, इससे मिल गया हमने आरजी। फिर हमने कैलकुलेट करना है आईजी। हाउ विल यू कन्वर्ट इट इनटू अ वोल्टमीटर दैट reads 20 volt at full deflection? 20 वोल्ट फुल डिफ्लेक्शन पे चाहिए हमें, तो V is equal to IG into RG plus RS। तो RS को वर्क कर लिया और ये इस पूरे की वैल्यू गिवन है 25। समझ आ रहा है? IG 25,000 volt. This is the maximum range that can have. Second time में this voltmeter 20 volt is the reading required. ये पहले कितनी थी 5 volt, so can equate this to 5 is equal to 5. Second time में IG तो same है, we require a additional resistance, let's say total resistance is R, and that become 24 volt. So here capital R is the total resistance, external वाला series और galvanometer का coil दोनों मिला के that total resistance is capital R. So divide कर लो, IG की वैल्यू आ जाएगी कितनी? IG will come out, sorry, divide the two, then we get R. IG तो कैंसिल कर लेते हैं, सॉल्व करने की जरूरत नहीं है। Divide the two, calculate the value of R. Divide equation 2 by equation 1. R divided by 25,000 is equal to 4. और पहले कितना था इसका ऑलरेडी? It was already 25,000. 25,000 वोल्ट उसमें ऑलरेडी था ओम रेजिस्टेंस, हमें एक्सटर्नल कितना लगाना पड़ेगा? We have to connect 75,000 in series. We have to connect extra 75,000 in series so that the range can be increased from 5 volt to 20 volt. राइट, बेटा समझ आ गया? ये इंफॉर्मेशन देने का तरीका अलग है। यहाँ पर 5 वोल्ट रेंज का हमने पहले वोल्टमीटर बनाया है। 1 वोल्टमीटर यानी 1 वोल्ट की पोटेंशियल के लिए काइंड ऑफ रेजिस्टेंस रिक्वायर्ड इज 5000 ओम। 1 वोल्ट के लिए 5000 ओम रेजिस्टेंस चाहिए, बिकॉज़ इट इज इन सीरीज, V is directly proportional to R. तो 5000 1 वोल्ट के लिए, 5 वोल्ट के लिए 25,000। If you want to make this reading to be range to be 20 volt, how much should be the resistance connected? Resistance अभी कितना होना चाहिए? That becomes 100,000. 25,000 already है, 75,000 हमें extra series में add करना पड़ेगा, so that the range can be increased from 5 to 20. Next. Question number 11, question number 10. In an ammeter, 0.5% of main current passes through a galvanometer. Total current I उसका 0.5% pass होता है galvanometer से, and the resistance of galvanometer is capital G. Then find the resistance of ammeter. The total current 0.5% passes the galvanometer, so 99.5% passes through the shunt. If there is a galvanometer and there is a shunt, it says that out of the total current only 0.5%. So 0.5 by 100 that passes through the galvanometer. The remaining 99.5, the remaining 99.5% will pass through the shunt resistance. दोनों को पैरेलल में हम इक्वेट कर देते हैं. Potential in parallel 99.5 by 100 is equal to 0.5 by 100 into RS times capital G. तो 100 gone, I gone. Shunt resistance आ गया G divided by 0.5 divided by 985. G by 199, that is the shunt resistance required. But the question is asking resistance of ammeter. It's not asking only the shunt resistance, how much is it. It's asking the resistance of ammeter, and in ammeter, these two are connected in parallel, the shunt resistance and galvanometer. It will be shunt resistance into galvanometer divided by shunt resistance plus galvanometer. Substitute shunt resistance as G by 199. Right, तो ये हो गया shunt resistance convert करना galvanometer को ammeter में, या फिर galvanometer को voltmeter में convert करना with the help of a shunt. Shunt is a low resistance in parallel, and capacitor को voltmeter में चलाना है, capacitor में. गैल्वेनोमीटर को एमीटर में कन्वर्ट करने के लिए दो रेजिस्टेंस लगाते हैं हम पैरेलल में, और एमीटर गैल्वेनोमीटर को वोल्टमीटर में कन्वर्ट करने के लिए हम वेरी हाई रेजिस्टेंस लगाते हैं सीरीज में. एंड वी आल्सो गॉट द फार्मूला फॉर देम. सीरीज में V वोल्ट मेजर करने के लिए कितना रेजिस्टेंस चाहिए, और सिमिलरली पैरेलल में कितना रेजिस्टेंस लगाए कि करंट आई वोल्ट में. ठीक है. दिस टॉपिक एंड दिस पर्टिकुलर चैप्टर बोथ आर डन. अभी हम नेक्स्ट क्लास में करेंगे. नेक्स्ट क्लास विल स्टार्ट द नेक्स्ट चैप्टर मैग्नेटिज्म एंड मैटर्स. से जो बचे हुए क्वेश्चन है करंट सेंसिटिविटी वाले, ये आप ट्राई करेंगे. वी विल डिस्कस दिस इन द फ्राइडे क्लास, सम फर्स्ट 30 मिनट्स और सो. बाकी सारे एक्सरसाइज आप करें या ना करें डीपीपी की, बट यू हैव टू डू दिस वन, द मैग्नेटिज्म एंड कन्वर्जन इनटू एमीटर, मूविंग गैल्वेनोमीटर कन्वर्जन इनटू एमीटर एंड वोल्टमीटर. ठीक है. सो फिनिश दिस डीपीपी. और उसके अलावा मैंने मैग्नेटिक डाइपोल मोमेंट और टॉर्क वाले कुछ हमने की थी हमने. Those have been also sent to you. Empirical law, magnetic force of current wire, and knowledge drop. So finish all these exercises from this chapter. We will start next chapter on Friday. Friday, pehle hum karenge doubt. We also have one more class in between. So Thursday, we will have the next chapter, and Friday we will have the doubt class. Okay, then that's it for today. Thank you. चैप्टर खत्म हो गया है. सलमाना से आपसे क्वेश्चंस करना स्टार्ट कर दीजिए. Finish it fast.
Thank you, sir.
Okay.